Hello, this is Mr. Humbard here. For this video, I'm going over the Chapter 9, Section 1. And for Chapter 9, Section 1, we have a g of 6.67 times 10 to the negative 11. And this is our constant we're going to use for our equation. For all these problems, we're using the following equation. F equals g m1 m2 over r squared, where r is some distance. You might also see that r as a d. It can mean the same thing, but it's always read from the center to the center of a spherical object if they are set as such. So everything except number 4 is the 2 decimals, and we're using scientific notation here for these as well. So the first problem uses that relation. We're finding the force. So we do force equals 0.15, 0.53. Now don't forget my g value of 6.67 times 10 to the negative 11. Divide all that by my distance, 0.54 squared. And I should get my 1.82 times 10 to the negative 11. If I go into my calculator and I type that in, I do my 6.67 times 10 negative 11, which means the same thing because these are similar to each other. Times 0.15 times 0.53 divided by 0.54. We're going to square that. And I get my answer. Notice I round that number because it's above a 5, or a 5 and greater. So 1.82 times 10 to the negative 11. Now, a quick note about scientific notation on your calculator with the E. This 6.67 times 10 to the negative 11, we can just state that, store it on these types of calculators as G. So if I hit that storage key, so storage down here, then I hit alpha, and I do some constant, a letter, I can store it as that letter every time. So if I want that value, I can just store it, and this of course means the same thing as that. So times 10 to the power is E in our calculator, and that's that second E here. Okay, so there's our first problem done. Our second problem is exactly the same idea. We just plug in a force. Make sure to square the bottom. There's 2 of those, so we square that, and we square the bottom one. Get some answer. We'll get that answer, 8.02 times 10 negative 11, like so. That's in newtons. We could type it in our calculator quickly. Do alpha g times 3.4 squared divided by 3.1 squared. So now I get the same thing, 8.02, and that's a 3 on the end, so I just round that down, 10 to the negative 11. All right. For this one's a little different, number 3. We have to find the distance between the two, their separation distance. It gives us the mass of both of them, and I have a force. Also, with the force, it's written out with zeros, like a bunch of zeros. I can fix that by just going from this decimal to that number. So like 1, 2, 3, 4, 5, 6, 7. So it's going to be 7 decimals from this decimal over to that, right next to that number. So I read that as 3.5 times 10 to the negative 7. That's an easier way of writing that. This is what's called scientific notation. I just have to move this over. If I'm going to the right, I make this a negative value. If I'm going to the left, I make that a positive value. So that's going to be a little easier to write out. And my equation is going to be written out like so. So I write out my original equation. And I want to solve for r, so I replace r squared and f, because I can do that. Just multiply both sides by r squared, divide both sides by f. And now I'm going to square root both sides. So r equals square root of g m1 m2 over f, like so. Now I'll plug everything in. I'm going to do my g value, 6.67 times 10 to the negative 11 times 73 times 86. Divide all that by my f. Like so. So my r, I can find all that. My calculator. So I do the square root of, I want 3. Oh, not that. But I don't want those numbers, I can erase it. I want my g times my masses, 73 times 86, I think it was. Yeah. And divide all that by my value. And I'm always careful to use a parentheses here, because if I'm not, I could forget something, and that was 3.5 times 10 to the negative 7. So always use a parentheses when you're dividing by something. If you're putting powers there, you might make a mistake and multiply, especially if you're using the other form. And I get 1.09. All right. And that last number is a 3, so I can just round that down. Number 4 is the last one that's a little different. So we have to find the mass here. And this is also, make that in scientific notation. 1, 2, 3, 4, 5, 6. I think I counted wrong. 1, 2, 4, 5, 6, 7. 7.3 times 10 to the negative 7 is my number here. That's my force. Here's my mass. Here's my distance. I want the other mass. So I have one mass, I don't have the other mass. So to do this, I use my equation. Probably the easiest way to do this is just to solve for what you have. And then figure out these two things, which I have the force, and I have this, and I have this. I can just solve all that and then divide it over. So I'll do that. So 6.67 times 10 negative 11 times my mass, 74, 731, divided by my distance squared, 23 squared, times m2, and I'll find what this is, and once I have that, I can just solve that out. So On my calculator, I'll write out my g, multiply by my value of mass, and divide all that by my value, my distance. And now I have something on one side. This is just a number. Oh, that's a -7, isn't it? So 7.3 times 10, -7 equals, and I keep all these values, 9.422604348 times 10, -9, m2. And I can just solve for m2 here by dividing this to both sides, because this is just a number. So I'll do that by going into my calculator, and I'll do 7.3 e -7 divided by that answer. And that's going to take the previous answer, so I do second, then an answer down here, and that's going to put it there. And that's going to give me my value, 77.4, but I round that, so that's there. And the rest of the problems are just a distance problem, which we've done. And another force problem, or another distance problem, which we've also done. And then another force problem. So that's it for this assignment. All right, have a good day. Make sure to put these in scientific notation.